I'm Toli, which is short for Toli Apostolidis. But you can call me Toli, that's fine. I'm lead developer at Gazprom Energy. That's not me on the picture, by the way. It's just a random picture of a Greek guy, which I thought will do for now. So for those of you who noticed the imposter in the title, I'll give you a little bit of context. So I started from ignorance, obviously, here, but I've got an academic background in mathematics and mathematical physics, and then for the next 7 or 8 years, I tried to learn to write code and optimize problems, optimize problems using C#. And now I find myself kind of leading the web development aspect of Gazprom Energy's digital transformation. So it's quite a journey from not being a developer to being a developer. That's kind of like why the imposter word is there. What am I doing at the moment? So I primarily code in C# of the ASP.NET flavor. I think I have a slight obsession with learning. Currently, I'm trying to expand all my knowledge with different languages, different frameworks. And I'm particularly interested in tech for good, which really means to employ all my tech skills for social good. If anyone's interested about that, catch me after. So today, I'm going to talk about a language I very recently took interest to. I hope to clarify a bit about the hype of Golang. And obviously, as a .NET developer, I like to kind of put that in the context of .NET and the language that I work with every day, which is C#. So the action plan. So I've got an introduction to Go. I've got a demo. It seems to be a thing to write some code in these presentations, so I'll do a little bit of that. And then I'll go on to explain why you would choose Go. And then obviously I put my .NET hat on and say, well, why don't you just jump on the .NET Core bandwagon and write your next app in .NET Core rather than Go? So first things first, introduce Go. What it is, a bit of history, a bit of the characteristics and its features, and what its role is in web. So definition, Go, often referred to as Golang, is statically typed and compiled programming language designed at Google by 3 designers. Statically typed in the same way as C# is and many other languages, but compiled a bit different than C#, that's my understanding anyway. It's compiled to kind of directly to bytecode rather than to intermediate language, and it doesn't use a JIT. If I had to summarize Go into 2 words, my understanding up to now would be speed and simplicity. Speed is given by its kind of concurrence model and the compiled aspect of it, and simplicity by design, it's aiming to be less complex and less boilerplate code, which to an extent, I don't know how many .NET developers are in here, but you can't really say that about C# most of the time. So this is an example of simple, a few lines in Go. I really like this quote. Before I go into more about Go, Go has been described by several engineers here as what you see is what you get language. That is, the code does exactly what it says on the page. And that was their aim as designers, and that seems to be the whole kind of feeling about Go. A bit of history. So I don't know if anyone's written C++ in the room.
I have.
Any hands up? Good job. So I haven't written a line of code in C++, but apparently somewhere back in the past there was C++. Then the 3 main designers of Go actually thought, well, we have this common kind of dislike of some features of C++. That's putting it mildly, I guess. Let's design this new language. So they started doing that in 2007. March 2012, they released version 1.0. 6 years later, there was a logo change. What that tells me, at least it's an indication, that there were no breaking changes to the language. And for those Python developers in here, you know about breaking changes a bit, I'm sure. But recently there's been a proposal, I think in August 2018, to introduce generics and error handling in the 2.0 version of the software. I also should mention that Go is open source. So onto the kind of main features of Go, as far as I can tell. Again, design is meant to be readability and usability of the language. That it should be really easy to get started with the language, and it should be very easy to understand what it does. It is an object-oriented language, or it isn't. It is, I think, but mostly in terms of encapsulation. At least that's my understanding. There's garbage collection, memory safety, but the main star here is the concurrency, where up there, where there's a concurrency model inherent to the language, which makes it really powerful. So I may have hit a bit of a Go fan with this graph. And apologies to the C++ developers in here, or Python, maybe. Sorry, Connor.
I can't believe JS is so low.
JS, yeah, there we go. I just noticed that Go is in top right there, in the axis of efficient concurrency and beautiful straight code. No idea how that's defined or measured, but it's there. So Go is in the top right corner, and interestingly, C# is kind of creeping away from its main competitors, so all the C languages in Java, so that's interesting. So I found it was useful to put Go into that context. Finally, so Go seems to have less complexity as a language, and the way they've achieved that is to abstract things out. So abstract, not include some things into the language. A biggie here is inheritance. Constructors and classes, it has, but it doesn't. You don't really use them. Don't have any exceptions. No annotations, and famously no generics. Although they are proposing to include them in the next. In 2.0 version of the software. So it's generally things that Go doesn't have, but a lot of Go developers seem to like that. They like the fact that it's a lot simpler and doesn't have all the complexity that maybe C# has. So we're in a web meetup, so I thought I'd have to talk about web frameworks, or what the role of Go is in web. There's loads of web frameworks out there that you can use for Go, although I did come across a blog post of a guy who was advocating that you don't really need a framework, web framework, because Go has everything you need to build a simple web server out of the box. And that's what I'll try and demonstrate quickly now, just to give you an idea of how it feels to write code in Go. And also because I've seen other people write code in these type of presentations, so I'll do that. Step back, what do we need a simple web server to do? First of all, we need to process dynamic requests, so user browsing, user posts. Serve static assets, so your images, your styling in JavaScript, and obviously accept connections to the internet via ports. So I'm going to go and sit at my laptop now, and I'm going to go into the demo. So I have mentioned that I obviously write in .NET, and I'm obviously using Windows, and I'm obviously going to use a Microsoft product to write code, Visual Studio Code. Although I have found lately that a lot of developers, especially web developers who hate Microsoft, are starting to use Visual Studio Code because they like it. Is that right? Yeah, good. So that's what I'm going to go for. I'm not going to show you how to install Go itself, but it is really not that hard. I did have a problem with my laptop earlier, so I had to switch laptops, so I did generally install it earlier on this laptop.
One thing I'd recommend is zooming in for the
yes.
Like the back.
Do you need zooming in the back? Anyone? Can you see this, or do you want?
Can you see at the back?
How do you zoom in?
Control plus.
Control plus.
Oh.
Is that good? Is that better?
Yeah.
Cool. So just to prove the case, it goes installed 1.11.4. All I'm going to do is I'm just going to create a simple file called main.go. And I'm going to create a package. So my package here is essentially how Go bundles code, bundles functions together, as you would expect. All I need here, once I've got a package, I'm going to write, as you expect, a main function. And I'm just going to write about 6 lines of code. That's it. I'm not going to go too much. So first of all, I'm going to call something I don't know how to. I'm going to create something I don't know how to pronounce. MUX. Do you know how? MUX. And what this is, it's a router. It handles all your kind of routing aspects of things. I don't want that. There we go. Then next thing is I'm going to call the handle function on this for the roots of my URL. And finally, I'm just going to create a call use HTTP package to serve, listen and serve. So I'm going to pass in a port. Then finally just log the error that returns. There's a lot of things I could probably talk about in this few lines of code, but I guess an interesting thing is that at this point I haven't saved yet. I've got a package and I've got 4 lines of code, and I'm already using a couple of packages that I haven't really referenced here. The HTTP package and the log package. Once I hit save, they get imported automatically. So what I've done here, I've just created a generic web server that doesn't do anything at this point. This home function should have squiggly lines underneath, but I don't know why it doesn't have it. But essentially, what I need to do, I need to customize my web server now. So what do I want if someone browses to my root URL, what should happen? So to do this, all I need to do is implement the handler interface. So this is the last line of code I'll write. Response writer, so I'm going to pass in a response writer type, which will just handle requests and write response. It will be used to write response back to the user, and then pass the request. That's it. So at this point, now I've got squiggly lines. At this point, all I want to do is I'm going to do the very stereotypical Hello World app, where I'm just going to go Hello World and go. That's it. So in 18 lines of code, I've got a customized web server that just writes out Hello World. What have I got wrong here? HTTP request. Funk. That should be called home. Thank you. You're watching. Good. So now to run my app, I just need to run this command, and that won't write anything out because I haven't actually printed anything. But if I go to my URL, it should have Hello World from Go. That's it. So what I've achieved here is nothing special, but I've managed to write a simple web server that handles the 3 kind of prerequisites we had earlier on. Obviously, from a web server or website, you're expecting some templates, some HTML, some static files. So I'm not going to write all that code now, obviously, although it's not hard, but it's really hard typing in front of people. So I'm just going to bring out a branch that I created earlier on. And now I've got a folder structure. The key thing here is I've got a UI folder and a CMD folder. So in the CMD folder, you'll find all the Go code. to Go files, and in the UI folder you'll find all the kind of web stuff, so kind of a proper separation of concerns. You have your HTML folder here, and your static files, which I won't really go into, but they don't really have anything in them. And you have, but the key thing here is your HTML files. So from a typical web framework, you'll expect you'll have your home page, which is a template here. Your HTML doesn't have much in, but the main thing is your layout file here, which has got all the code that you expect. There's no color coding on that, but looks better.
An extension account.
Yeah, I'm not going to install that now. It looks a lot nicer on my other laptop. So, and then you can implement a partial class, partial type template, which you can define your footer, for example, and then reference it from your layout or any custom page. So that's it. That's your templates. I've got my main.go file, which is the same, almost identical code that I just wrote, with the addition of these two lines of code, which are responsible for serving the static files. So we ticked that, one of the three prerequisites that we had earlier. And then we have the handlers.go file, which has your home function, which we wrote earlier, and it's a bit more elaborate. It's got hard-coded the files in here, but that's just for a demo. And as you would expect, it'll take your files, it'll parse them using the template package of Go, and then it will execute it here. That's all that'll do. And if I just go into PowerShell, I need to use PowerShell because I need to run both Go files here. And then go to my page. That's it. That's a web page that serves static files, parses and executes templates, and does everything you expect from a website. So it's pretty simple, and the key thing here is the idea of the handler. So if you think of the controller in MVC, it's kind of similar, although Go does have MVC web frameworks, but you can simply use this handler pattern to implement a web page. So I'll stop that. And I'll quickly go back to the presentation. Will that present from the start? So then I asked myself, as the third item in this action plan, so why do I use Go? I was failing. This is something I wasn't aware of before I started this presentation. As I said, I am an imposter in this whole world of software. But this is a law that was kind of observed by one of Intel's, IBM's or Intel's co-founders? Yeah, thank you. So you know about it.
Yeah,
good. That the transistors, the number of transistors double, but the cost halves.
Double in 2 years, is it?
Yeah. And that will go on forever. Basically, that was the assumption. So it would grow exponentially. Great, yeah. So actually, that didn't happen. It happened during the 80s and the 90s and 2000s, but it started tailing off after 2010, and actually in 2017 it started slowing down. So yeah, so going back to the whole Moore's law, that didn't happen. What that tells me as a developer is that we need to look at our languages that we use a bit and how we code, given the fixed servers we have in a way. So they're not going to get better like we thought we would. So we can't just not think about these things. So the real reasons behind the hype is not the fact that you can write a web server in 20 lines of code. I use that example just because we're in a web meetup, really. It's these four things, this concurrency model that gives Go so much hype, I think, amongst the Go developers. Go has a notion called Go routines, which you can see as lightweight thread of execution. Just to check, how many of you guys have heard of Go routines before you came to this? Great. Okay, so you can think of Go routines as, actually I've got a slide for this next, but it also has a primitive, concurrency primitive called channels, which are pipes that allow the coroutines to talk to each other, and another primitive called select, which lets you wait on multiple channel operations. So all this is built into the language. That's what gives Go this powerful kind of concurrency model. And finally, the compiled aspect of the language, more or less like C and C++, as you would expect from the designers, makes it a lot faster. So this is, I think, I can tell that the biggest reason why people love Go and get really excited about it. Go routines. So this is a simple example of Go routines. This f function has been defined somewhere outside the main function, but you can either call it like this, which is a normal function called, or you can call it with a command Go before it, and then it becomes a Go routine. So it starts a Go routine. As you see in the graph there, that's quite a nice graph that says, right, I'm just going to start maybe that red line, I'm going to do what I need to do, and then I'll stop doing what I'm doing. So Go routines are really cheap to start, as opposed to threads. They use very little memory to start with. They can grow, I think. And they generally, you can have multiple Go routines per thread. So there's a one-to-many relationship. So in a typical thread, you can have many Go routines. So that makes the language really, really powerful. Finally, I think the pizza is here, so I'll be quick. I then put my .NET hat on. I said, well, why not jump on the .NET Core bandwagon? If I'm going to decide to write an app in the next year, why should I write it in Go and not write it in .NET Core? For those of you who are not familiar with .NET Core, again, show of hands of how many people in here know what .NET Core is. Great, so most of you, good. So all this is marketing jargon from Microsoft's website, but basically it's the ASP.NET Core is the .NET Core main web framework offering of Microsoft. And it's cross-platform, and it's really, really fast. What does .NET Core has? It has concurrency in the form of async await. I am aware of the n+1 problem in the concurrency model. That's a point to me as an imposter. Did I know that? It also has a lot of simplicity. I know I mentioned that C# has a lot of boilerplate code and it's like a steep curve to learn maybe, but it's actually getting a lot better over time. It's got a web framework, as mentioned, ASP.NET Core, and it's also really, really fast, mainly because of this new web server that they built, Kestrel, which is really, really lightweight. However, you can't use it in production, which is the issue. .NET Core is also open source. Microsoft have done a lot to open up to the dev community lately, and I think we haven't seen this type of behavior for them in ever, I think. So it's been really, really good, and it's also .NET Core is also genuinely cross-platform. So targets all popular operating systems. So before we go, a quick demo of a performance profile between Go and .NET Core. Show of hands, who thinks Go will perform better than .NET Core? 2.2. 2.2. Because I installed it today, so I got the latest. I had to install it. No one for Go? Okay. So most of you think .NET Core, then it's going to be faster.
.NET fanboy, so .NET, I'm afraid.
All right. Okay.
I'll eat my hat if I'm wrong.
No, that's fine. I'll go for it. So. Most of you probably know this, but I'll just demonstrate how easy it is to genuinely start a web application in .NET Core. So if I start with, obviously, checkout again. That's there. Okay. So all I need to do is again check that, just to demonstrate which version I've got there. Can you see that? 2.2.103. And then all I need to do is run the new command, .NET new, and then use one of the templates that .NET Core provides. And you'll now see loads of green files on the left there with controllers, models, views, and essentially implementing the MVC architecture. And then it restores any packages that it needs. And then all I need to do is literally call .NET Run. And if I go to my web browser, do you reckon this is too fast? One sec. It didn't take that. It wasn't that slow on my other laptop. Loads of issues. Oh.
Oh, do you need to do .NET Restore?
No, it's done .NET Restore.
Okay.
Anyway, I'm not going to debug this here, but believe me, it works.
And it's faster.
A lot faster. So I'm going to get rid of all this because it's terrible. What I'm going to try and do, I'm going to run 2 web servers, one built in Go, one built in .NET Core, and just quickly demonstrate how they differ and what's faster. So I'm going to run, I'll probably have to go into there. I'm going to run the .NET file in the .NET web app in release mode. And I'm going to also run the Go app. Oh, sorry. One sec. It's in there. CMD app .go. I think that's right. So I've got one web app in Go there, and the other one in .NET Core. They look really, really similar. They're just powered by 2 different languages. That's it. So I'm going to use a tool called Bombardier that actually, I'm going to stop one of the 2 so it's not unfair. Which one shall I go with first?
Go.
Go? Okay, go for Go. Go for Go. That should be running now. Yeah. So what this does is it opens 125 connections, and it tries to hit that endpoint 50,000 times. That's it. So it really kind of, it's maybe not as realistic, but it gives you a benchmark, and it returns some stats of how many requests per second you achieve and what throughput you have. And as you notice, it's pretty slow. So are we still confident about Go, I guess, compared to .NET Core?
While you're waiting for that, have you also been on a wind up to AWS stuff? See if that makes any difference to the results.
That's a great point. Maybe maybe do that next time. Because
just because you're waiting, the .NET Core stuff does run really quick on the online.
Does it?
Really quick. I wouldn't say it's faster than that, because of all the new spam stuff that you return refs.
Right.
Really easy to look at.
Is .NET Core really a lot faster because of Kestrel, though?
Well, Kestrel, when they developed Kestrel, they actually developed the new spam T stuff, which is the way you're returning pointers without them being pointers. the like windows onto the memory without the quality you get in C++.
Can we put a beep on that?
I love that technical sound.
So, so that's returned with some of them failed. It's probably something to do with the internet. I don't know why, but you got a throughput of 1.62 megabytes per second and a requests of 738 per second. Now, if I go and stop one and start the other, this is now really, I think this is the recording.
I think it's gone really small. I think you just need to manually.
No, I don't think so. Oh, yeah, you're right. So, stop that one, start .NET Core again. It's going to take some time to start. So what do you think? Going to get better or better than Go?
I like to think so, but I have no empirical backing to that at all.
So it's looking a little fast. I like this this progress bar. It's exciting. I've started watching it a bit while I was testing this. So the indication is already that .NET Core is a lot faster. Initially, when I ran this, because when you do that .NET new MVC, that has logging. There we go. So it has a 5 megabytes per second. The difference in reality is not that big. I think because I'm recording now, there's. I think the difference I found was like it was two times as fast, but that's it. So I guess for me, both of them are really fast. But it's nice to see the .NET Core is actually performing really well as a .NET developer. So to finish off, I was looking for a way to finish this off, but I found this quote which I really, really identified with, which is, it's always good to learn and stretch your mind. Even if learning Go never lands you a job, not looking for a job, Fred. You will gain new perspectives when using other languages. For me, that's really, really true. I learned a lot about how web frameworks work, how web servers work, how concurrency, what is concurrency, and it's really, really useful to learn. Now, if any of you are interested in what kind of organizations in the UK are using Go, and by that I think they have GitHub repositories in Go, so they're not really just saying it. Here you go. And for those of you who know me, you probably can pick out the organization that I'm a bit of a fan of. And they use Go, and they built all their stuff in Go. Finally, how did I get started with Go? I haven't really. I got my first exposure in October. And the first point I would say is the guys at InfinityWorks are doing great work engaging with the community. They're offering workshops for free, and they're really, really good. So I can't praise them enough for that. Let's Go is a book that I bought and is really, really useful and very nice examples. And generally on the web, Go is the resources are very good. So maybe that says something about the simplicity of the language or just the passion of the developers. And finally, if you want to find out stuff on your own for Go, here's a list of resources that you can use. Especially this one is just a half an hour talk. Has anyone seen this video by Rob Pike? You've seen it. It's very good. The difference between the fact that concurrency is not parallelism. And he advocates all the positives about Go, I guess. And he's one of the 3 designers. Sorry?
You made that mistake in an earlier slide. So Go routines are parallel when they're not very concurrent.
Yes, exactly. Yeah. And that's where I found out the difference. That's it. Thank you. Just to tempt you.